Welcome to The Explainer. Today, we're diving into a theory that proposes a pretty radical new foundation for all of physics. And it starts by saying we need to correct a century-old mistake we've been making about the very nature of empty space. For decades, the struggle to unite quantum mechanics and general relativity has been treated like this ridiculously hard math problem. But this theory we're talking about today, dynamic vacuum field theory, or DVFT, it argues that the problem isn't in our equations at all. It's ontological. It's in our fundamental assumptions about what's actually real. The central idea. We've just completely misunderstood the vacuum. All right, so here's our game plan. First, we're going to look at why physics is stuck in this stalemate. Then we'll introduce DVFT's core idea that the vacuum is a real physical thing. From there, we'll see how this one idea seems to naturally unify gravity and electromagnetism, explore how it might solve some really deep puzzles, and finally, we'll get to the good stuff, how we can actually test it. So let's get started. Why is physics stuck in the first place? Okay, let's really dig into the core problem that DVFT was created to fix. And it all begins with a fundamental disagreement about the nature of, well, nothing. Think about it. Our two greatest theories made completely opposite bets, and according to DVFT, they were both wrong. On one side, you have quantum mechanics, which sees the vacuum as this probabilistic stage, a foam of virtual particles, but it's not a primary physical thing. On the other side, you've got general relativity, which turns the vacuum into pure geometry, an abstract canvas that can bend and warp, but it has no actual physical substance to do the bending. And that split created a massive wall right down the middle of physics. By saying the vacuum couldn't be its own independent physical thing, both theories made it basically impossible to find a common source for everything. Unification keeps failing because gravity is left floating in this abstract geometry, and all the other forces are acting on a totally different kind of stage. So DVFT comes along and proposes this single, really powerful correction to that foundational error. It says, let's put the vacuum back where it belongs. It's not the stage, it's the main character. The entire theory starts with just one root object, the vacuum phase field. And as you can see, this isn't just some clever math. It's meant to be a real physical field that has both a density and a complex phase. The whole proposal is that everything else we see, matter, forces, you name it, is just a different pattern or behavior of this one single underlying field. Now here it is. This is the absolute engine of the entire theory. It's not just a convenient mathematical trick. The theory argues that the universe's fundamental topology forces the vacuum's phase to break apart into two totally distinct components, a smooth part and what it calls a defect part. And these two components behave in completely different ways. The smooth phase is kind of like a calm, elastic medium. It leads to these predictable, linear, bell curve-like responses. That's the Gaussian part. But the defect phase, that's where you find topological knots and twists. Think of them like tiny whirlpools or cracks in the field. And these defects introduce sharp, chaotic, non-Gaussian behaviors. This one distinction, this is the key to everything. So, okay, we have one field with two different personalities. How does that help? Well, let's see how this one field gives rise to the two fundamental forces we've been trying to unite for a century, gravity and electromagnetism. And right here is the core claim. In this view, gravity and electromagnetism aren't different forces that need to be smashed together. They're just different ways the same vacuum field behaves. Gravity is what emerges from the smooth, large-scale curvature of the phase. Electromagnetism, on the other hand, is what arises from those sharp topological defects inside of it. So you see, the unification isn't something bolted on at the end. It's an unavoidable consequence. The moment you decide the vacuum is a physical field that can be both smooth and defective, these two forces just pop out automatically as two sides of the same coin. Okay, but a new theory is only as good as what it can explain, right? So let's see how this new way of thinking tackles two of the deepest, most stubborn mysteries in all of physics. First up, the famous equivalence principle. For more than 100 years, we've known this is a fact of nature. Einstein even built his theory on it, but we've never really explained why it's true from a deeper level. DVFT claims it can do just that. The answer, in DVFT, is actually shockingly direct. Inertia is just the vacuum pushing back when you try to accelerate something's phase through it. Gravity is just an object following a pre-existing slope in the vacuum's phase. It's the same vacuum responding to the same phenomenon, a change in its phase. So of course the response is identical. All right, now for the second puzzle, the quantum measurement problem, specifically where gravity gets involved. I mean, this is the real fault line where quantum mechanics and general relativity just completely fall apart. DVFT gives us a really clear step-by-step story here. So before you measure anything, the particle is a spread-out coherent wave in the vacuum, and its gravity is just as spread out and wave-like. Now, here's the crucial part. Because gravity comes from the smooth part of the phase, it actually preserves that quantum weirdness. It doesn't cause a collapse. The collapse only happens when an electromagnetic interaction, a defect, comes along and locks the phase in place, snapping both the particle and its gravity to a single point. And this puts DVFT in direct opposition to other major ideas, like the Penrose-Diosi model. Penrose says gravity is the thing that destroys superposition. DVFT says no, gravity participates in the superposition. The collapse is caused by a totally different mechanism, an electromagnetic topological defect. This isn't just philosophy, it's a real, testable fork in the road for physics. And that brings us to the most important part of any real scientific theory. You have to be able to test it. DVFT moves beyond just explaining old puzzles and starts making new predictions, pointing to exactly where we should be looking for new physics. And here is the theory's boldest, most dangerous prediction. The equivalence principle, one of the most precisely tested ideas in all of science, isn't perfect. It should break down. If the vacuum is a real physical medium, then just like any other medium, if you push it too hard, its response should become nonlinear. And right there, in those nonlinear moments, we should see tiny diagnostic cracks start to appear. And it's not just a vague idea. The theory gives us a specific hit list of signatures to look for. It predicts tiny differences in how things fall based on what they're made of, their quantum scale, or even their acceleration history, like a kind of memory in the vacuum. This takes a deep philosophical idea and turns it into a concrete to-do list for experimental physicists. So you might be wondering, if these violations exist, why haven't our super precise experiments already found them? Well, the theory has a neat answer for that too. It says all of our tests so far have been in calm conditions, where the vacuum's response is nice and linear. These new effects are only predicted to show up in extreme environments, like right next to a black hole, or in incredibly subtle, low-acceleration situations we haven't properly tested yet. You know, it all really comes back to this one core idea, a simple but incredibly profound distinction that seems to resolve so many paradoxes. The smooth, coherent part of the vacuum is what we call gravity. The knotty, topological, defective part is what we call measurement and electromagnetism. And so DVFT leaves us with this really provocative question. For hundreds of years, physics has been about studying the actors, the particles and forces moving around on the stage. But what if the deepest answers aren't in the actors at all, but in the stage itself? What if the vacuum isn't just the backdrop for reality, but is its very source?